if the book were to ask you to plot or to graph, this is what they'd be looking for. Here in this example it says plot -3 on a number line. So I've drawn a blank number line here. Plot basically just means represent it, so we'll put a dot there at the -3 position. So let's label this. Let's see, we have 0, which I usually put in the center. -1, -2, -3. And for plotting at -3 on the line, I'm going to put a dot, a closed dot, because it shows that that's exactly what it's equal to. Okay. As far as negatives go, negative you can think of as opposite. It negates things. So negative is opposite. In other words, talking about the additive inverse. Remember, inverse is basically the same thing as an opposite, or if you don't remember, just know inverse is the same thing as saying opposite. So, talking about pluses, the opposite of a plus is a minus. The opposite of a positive is a negative. So here, a negative in front of a 5 equals -5. It's the exact opposite idea. Or here, if I had -5, or I could have written it just with two negatives touching. I could think of it as saying the opposite of a -5, which is 5. Or I could think of it as, hey, I have two negatives holding hands here. They're going to cancel to give me a 5. So I get the opposite of whatever that negative is in front of. And I personally like to think, oh, when I have two negatives holding hands, two negatives touching at any time in math, they turn to plus. They kill each other. And I say when they hold hands or when they're on top of each other. If I have two negatives, close proximity like that, basically touching, they always will kill each other in math. That's something you'll see consistently. So negative, negative, or a negative divided by a negative is the other time you'd usually see negatives. Okay. Absolute value. This is kind of a big deal. This is something that you may not be as fresh on. Absolute value is the distance that some number is from 0. And when we say distance, we are talking again about that number line. How far away, how many steps are we from 0? So let's start by looking at 2. And I'll show you literally what it means. Notice that the absolute value symbol is two straight lines around the number. That means absolute value, or what is the distance from 0. So absolute value of a 2. I'll draw the number line. The distance from 0, let's see, we take 1, 2 steps. So we have a 2 here. The answer to the absolute value of 2 is 2. Same idea over here for -4. We have again absolute value bars, which are just the straight ones. That's how you can recognize it. 0, 1, 2, 3, 4. So when you count the steps out, there were 4 steps. That's the distance. The answer to absolute value of 4 is 4. Now notice something for me. Here we had absolute value of a positive number, and it gave me a positive answer. And we had absolute value of a negative number, and it gave me a positive answer. Absolute value is always positive. It's always plus. Now I've written that again here for when I scan these notes for you. The 2 bars is an operation. You have to actually do it. Basically what it does is whatever's on the inside, you just keep the number and write it as a positive. Because again, you're discussing, you're representing the distance from 0. Let's look at a few examples together. The absolute value of 0. Well, how far is 0 from itself? 0. The absolute value of -7. Well, you can think of it as distance or as just dropping that sign. That gives me a 7. Absolute value of 9 gives me a 9. So again, notice we're getting all positive answers here. You just keep the number and drop the negative, but you're only looking on the inside of these each time. Notice in each of these examples there was nothing in the front. It was just looking at the inside and taking the absolute value of what was within those bars. Now I want you to look at something. Notation. There is a difference between these two things I've represented. Here I have negative with two straight up and down bars. So negative absolute value of 2 on the inside. And I want to compare that, so I'm going to say versus negative 2. Over here we said the absolute value really was an operation. So we'll take that into consideration. We'll do that first. Absolute value of 2, I get a positive 2. And then of course that negative, well, we haven't even talked about it, so it has to come down. It stayed. It was not inside the bars, so it carried down to the number. Versus over here, these parentheses aren't doing anything. They aren't performing anything. They were just showing that 2 was inside. So this is the same thing as negative 2, or you could think of it as the opposite of 2. Either way, you get a negative 2. So in these two examples I've given you, yeah, you're getting the same answer, but your thought process was different, the way that you got there. The reason that's important, let's look at a slightly modified similar example. Negative absolute value of negative 3. Let's see. So the operation absolute value of negative 3 is going to give me a positive 3. And then we bring down that negative. So here I get a negative 3. Because you do it in order, absolute value gave you positive and you bring down the negative. Kind of tricky. Look over here though. Versus negative, negative 3. Again, you can think of it two ways. The opposite of negative 3, which is positive 3. Or you could have just said, oh, negative, negative 3, those cancel to give me positive. So in these answers, you get something very different. You have two negatives touching over just parentheses, or without parentheses if you had not written them, and you get a normal positive 3. Versus with that absolute value, guys, you have to do absolute value first, and then you worry about stuff on the outside. So that's why the negatives did not cancel here. You first did absolute value, then you said, oh yeah, and I had a negative in front, and you carried that down.